already running a bit late, so we quickly move to the next speaker, Shommo Das from ISI Kolkata. So I'm not extending introduction of Shommo because we are a bit late. So Shommo, you can share your screen, and by the time you share, I just tell you that I'm recently following one of your paper. So Shommo, please continue.
Yeah. So, hello, Oniman sir. Thank you. So, am I audible, sir?
Yes, yes, you are audible, visible. Just make it full screen. Absolutely fine. Continue.
Okay. So, thank you, organizers, for letting me to present my talk in this international conference on quantum information and foundation. Especially Professor Guru Prasad Kaur. We are all his student, and we have taken his class since my beginning of my PhD, and now it's my end of my PhD. So, thank you, sir, for giving this opportunity and teaching us quantum information. So, let's start. My talk is maximum violation of monogamy of entanglement for indistinguishable particle. It's a joint work with my supervisor, Professor Paul, Gautam Paul. He's a professor of cryptology and security research unit at ISI. And Dr. Anindya Banerjee is a research fellow at Center for Quantum Technologies, NUS. Previously, he was Professor RP Sir's group. So this work is based on our paper, that is maximum violation of monogamy of entanglement for indistinguishable particle by measures that are monogamous for distinguishable particle. This is published in 2021 in Physical Review A as a letter. So okay, sorry. So let's start with this puzzle. Uh, Suppose in an office, identity cards are issued to employees, different employees, to distinguish them and track them for some specific task. Okay, but if identity cards are not associated with that employee, then we cannot track each employee. In the figure, you can see there are two employees who are identical in nature. Okay, but they can be distinguished with their ID cards. And in the right hand side, there are two indistinguishable employees which are same alike and they cannot be distinguished. Now, suppose a specific task is assigned to this group, distinguishable employee and non-distinguishable employee. So, can that task be still completed? This is question number one. Question number two, can the efficiency of the task be improved when they work with identity card or without identity card? Is there exist some specific task which can only be done with the employees having identity card and the employees without identity card? Now, this type of question may be a bit non-trivial in the real life domain, that how identity card may be affected in a company. But we address this question when employees are replaced by particles, right? So let us now technically define what is meant by distinguishable and indistinguishable particles. Okay. Now, there are two kinds of particles in the universe. And one is identical particle, another one is non-identical particle. And identical particle, we have distinguishable particle and indistinguishable particle. Non-identical particle are always distinguishable. That's why I make this column distinguishable. Now, two particles are said to be identical if their intrinsic properties, suppose mass, electric charge, spin, color, etc., are exactly the same. Now, indistinguishable particles means identical particles like boson or fermions when each particle cannot be addressed individually. Suppose, let's understand this indistinguishable thing with an example. Suppose this is a particle A and B. They are completely identical and this is their wave function. Now, if A and B overlap in the left figure, they are identical but distinguishable by their label A and B. So we can label them as their wave function does not overlap. But their wave function, if the wave function overlaps, we cannot label them. So they become identical but not but indistinguishable. Okay, so this is a basic difference between how we can make two identical particles distinguishable and indistinguishable, right? So we let us answer the puzzle answers. So we have shown earlier that there exists indeed a set of properties, quantum properties or applications that are specific to distinguishable particle, specific to indistinguishable particle, and there may be some application which are more suitable for indistinguishable rather than distinguishable. So we show earlier in this physical review paper that unit fidelity quantum teleportation can only be performed using distinguishable particle. Okay, we using indistinguishable particle, we cannot perform unit fidelity quantum teleportation. And there is a specific kind of state, hyperhybrid entangled state. I am not going into technical details, you can find in this paper. This type of state is only possible using indistinguishable particle. Using distinguishable particle, we cannot make this type of state. And there are some properties which can be performed using distinguishable particle and also in indistinguishable particle. We show specifically entanglement swapping. This can be done using two particle entanglement swapping. Okay, so we have not found any scheme to entanglement swapping using two particle in distinguishable domain. So this is a unique feature for again indistinguishable particle. Okay. Now let us come to, we know all know that Professor Panigrahi earlier told about monogamy of entanglement. So we have in our social life monogamy of marriage, that monogamy is the rule of marriage with only one partner. Yesterday was Valentine's Day, so let's move to the technical details. That if two particles are maximally entangled, then none of them can share entanglement with any part of the rest of the system. In the figure, you can see if A and B are maximally entanglement and E is the entanglement measure, if A and C are also entangled, so this the joint entanglement is always less than their A given B. So mathematically, it can be written E for any entanglement measure, E of A given B, rho AB. This is the rho AB, and E of A given C, rho AC, less than equal to A given rho ABC. So, as Professor Panigrahi have explained this thing, I am not explaining this further. So, this has application in security of quantum key distribution, classification of quantum states, condensed matter physics, and black hole physics. Now, the next question is, does monogamy always hold? So let us first assume analysis that on basic which two properties monogamy depends. Monogamy depends the dimension of the particles and the entanglement measure we are using, right? So OU shown in 2007 paper that we know for qubits monogamy property always holds for concurrence, but for Q treats using squared entanglement measure, he showed that monogamy is violated. So for this state, he has shown this result where monogamy is violated. So we consider now we restrict our discussion for qubits as there are several monogamous entanglement measure in qubit systems for square concurrence, log negativity, entanglement formation, Rayleigh skew entropy, etc. So let us now characterize that what is meant by the violation, monogamy violation. First of all, define Emax is the maximum value of any entanglement measure E. Sorry. Now we define first non-maximal violation. If in equation 1, in this equation, E of A given rho AB is less than equal to Amax, E of AC rho AC less than Emax, but their summation is greater than Emax. Okay, then we say this is a non-maximal violation, which is shown in this one. Okay, the maximum violation if we have both these terms, E of A given B and A of A given C is both equals to Emax, then we get the non-maximal violation. We said this a maximal violation because this is the maximum possible violation. E of A given B cannot be greater than Emax. So for the both the entanglement term attains its maximum value. When both attains its maximum value, then we say it is a maximum violation. Okay. Now let us begin with quantum cloning. We all know that quantum cloning is different from what normal people know. This is actually meme that biologists can say we cloned a sheep, but quantum physicists say yes, but actually no, you cannot clone because we have a no cloning theorem. No cloning theorem forbids the creation of an independent and identical copy of any arbitrary quantum set. This is a famous result which was stated by Wouters et al. In 1982. So this is the formal proof of this or statement of the no cloning theorem. I'm not going into the details. It follows the fact that quantum operation must be unitary linear transformation. So this has application in quantum error correction, quantum cryptography, black hole physics. Now the question is there any connection between quantum cloning and monogamy? Yes. So this is all about why we define the maximum violation of monogamy and why we define what is meant by cloning. So maximum violation of monogamy implies cloning using distinguishable particle. Okay, suppose A and B and A and C both are maximally entangled. Okay, then using this protocol, we can have a cloning. How? Suppose phi x is an arbitrary quantum state and we measure a Bell state measurement with A and the output is Y. Then based on the output, if we perform unitary measurement both on B and C, then we get the phi state in both B and C. So we have two identical copies of this unknown quantum state, right? So this way, maximum violation of monogamy implies cloning, means the violation of this famous no cloning theorem. This is the relation of monogamy and cloning. Okay. Now we have an apparent violation. So in this figure, suppose A, B, and C are three particles and each having two DOF, 1 and 2. Suppose the DOF of A1 is maximally entangled with B1. Now DOF of A2 is maximally entangled with C2. Now forget about this thing, DOF view. Let us consider in particle view. So one can say, okay, A is maximally entangled with B, A is again maximally entangled with C. So we have a monogamy violation and no cloning theorem does not hold. But wait, if we go into the more detailed picture in the DOF view, degree of freedom view, then we have no, it cannot be done because A1 is not related to A2. They are two different degree of freedom. So we need to move from particle domain to degree of freedom domain to redefine the monogamy of entanglement. So this is the monogamy of entanglement generalized in the DOF paradigm. So it says the same thing that if any DOF, suppose AI is maximally entangled with any DOF of BJ, suppose, then AI is entangled with BJ and AI is also entangled with CJ, then it have to be restricted given AI BJ given CJ. So this is you can see clearly that the extension of monogamy from particle view to DOF view. Okay. So analytically it says if any DOF of A is maximally entangled with B, then this DOF cannot be maximally entangled with C. So we can see this figure that if A1 is maximally entangled with B1, then A1 cannot be maximally entangled with C2 or C1 or B2 or any other. Okay. Now we will state our main theorem that maximum violation of monogamy of entangled using indistinguishable particle, whether it can happen or not. Okay, so let us first try to represent two indistinguishable particles each having 2 degrees of freedom. Okay, so this has level alpha and beta. So uh, the ith and jth DOF are represented by AI and Bj. So the state can be represented by this product. This is a new notation defined by Lofranco et al. This paper is 2019 PRL paper. We have taken this their notation. Sorry, I forget to give the citation. And the density matrix can be represented by this. So uh, in this view, we have to given for monogamy, we have to trace out. Suppose these are entangled. This is entangled and this is entangled. So we have to define the trace out rule. Trace out rule for indistinguishable particle uh, is a bit tricky, and I'm not going into the details why it is tricky. We are just defining our main result. We're just going to our main result. This is the DOF trace out rule that suppose two indistinguishable, we have two indistinguishable particle A, B, and C, and we cannot label them. So we have to trace out any of the DOFs. So this can be defined by this DOF trace out rule. So this is proposed in our paper. I'm not going into this complex mathematical thing. So let us go into our main theorem. So our main theorem states that in qubit system, indistinguishability is a necessary criterion for maximum violation of monogamy of entanglement by the same measure that are monogamous for distinguishable ones. So let's concentrate on what actually we show. So what actually we show in this circuit that uh, in the circuit of Lee et al., they proposed a state which is using two indistinguishable particle A1 and A2. So what we show basically, suppose two indistinguishable particle we have, and with their degrees of freedom, suppose one indistinguishable particle is this place, another indistinguishable particle is in this place. So for I'm basically describing what we did, that two indistinguishable particle having polarization degree of freedom and path degree of freedom. This is a circuit of particle exchange. So this is a hyper-hybrid entangled state. Sorry, this is a hybrid beam splitter. This is HBS. Okay, so one particle spin down goes from here. This is hybrid beam splitter, and it goes to this is Bob side, or it can goes to Alice side. And similar, this particle can goes to this side, and this particle goes to this side. So we show that in this circuit, the polarization degree of freedom of Alice is maximally entangled with the polarization degrees of freedom of Bob, and simultaneously this polarization degree of freedom of Alice is simultaneously entangled with the path degrees of freedom of Bob. But again, they are indistinguishable. That's why we have a maximum violation. Okay, if there's a distinguishable, then we can do cloning. Okay, so this
Shommo, you have to
can
move a
be
bit
analyzed.
fast.
Okay, I will be in 2 or 3 minutes. Okay, so this is the state of the circuit, and we show that this one that they are both maximally entangled. So this is the result. So you can see this mathematical analysis in the supplementary material of this work. So now it's time for open question. So we show that in distinguishable domain, maximum violation of monogamy of entanglement leads to violation of no cloning theorem. But in indistinguishable domain, we say that monogamy of entanglement can be violated maximally. But no cloning theorem cannot be violated in principle in quantum mechanics. So which one is more fundamental, no cloning theorem or monogamy of entanglement? We don't know yet. Yes, this is an open question from my work. Again, what is the application of this maximum violation? We know that monogamy of entanglement is related to the security of quantum cryptographic protocol, black hole physics, etc. So what happens this maximum violation of monogamy of entanglement? We again don't know what is the again explication. And there are some other correlation like steering, coherence, discord, etc. So is there possible that maximally violate this correlation? So this is an interesting future action I would like to study, and if anyone want to collaborate, so I'm open with this work because I am not an expert in steering, coherent, or discord in any of the things. So this is my open question, and the last slide, obviously, the publication site. So I am a part of Professor Dr. Paul's quantum group at ICI. So this is named Quantum Information, Computation, and Cryptography group. So we have 2 postdocs, 6 PhD students, and 3 master students. 6 PhD students work in different fields of quantum computation, cryptography, and information. And these are my related work in this domain. So this one is hyper-hybrid entanglement, indistinguishability, and two-particular entanglement swapping, published in Physical Review A. And these are the 2 papers currently communicated, monogamy and cryptographic application of entangled indistinguishable particle. Here we show some cryptographic application of this indistinguishable monogamy, and the generalized relation for teleportation fidelity and singlet fraction for distinguishable and indistinguishable particle, and its cryptographic application. These 2 are communicated. And finally, obviously, I have submitted my thesis at ICI, and currently I'm looking for a good postdoc opportunities. So if any of the professors think my work is interested, so I will be happy to join their group as a postdoc. So thank you, Professor Pathak.
Thank you, Shomo, and I wish you good luck in getting a postdoc and also success in addressing the open problems which you have listed. So we are running late, so we'll take a quick question, and there is already a comment in the chat room. So
yeah, okay.
can you answer that?
Okay.
Means
okay, let me see that. Okay, which one is
in the chat there is only one comment.
Related to locality information pointed out by Benetti et al. Would you like to comment? Yeah. So what Benetti et al. Has surveyed these physical reports, they have surveyed 4 different types of indistinguishable approaches. So one of the approaches and the recent approaches is the Lofranco et al. What we have taken in this literature. Okay, so there are many other approaches, and also obviously in this physical review report there are some issues that how to improve these approaches. So obviously this is the Lofranco's approach in 2018, and this is 2020. So this is the most recent one. Okay. So if you have more question, you can obviously contact me in my email ID. Okay.
Is there any other quick question or comment? So if not, let us thank Shomo once again and move to the next talk, which is also on a very interesting and up to the top